Okay, so today, see, it will be very important chapters because today we would be dwelling on the properties of inverse trigonometric function, and the main thing which will be there in the properties of the trigonometric function would be that at times you would be jumping the principal branch value, and then you simply need to ensure that you have to come back therein. So that's the only thing which you have to ensure. Rest all things are too simpler. In my previous lecture, I have given you a table wherein the principal branches of the trigonometric functions and their inverses, that is given to you. So today let's do few more properties here. So first property, of course, was regarding this tan inverse of this minus x, any trigonometric function minus x. So what it would be? So what we have seen earlier was that if the principal branch of a function was lying between minus pi by 2 to plus pi by 2, and that is for the three functions, namely sine, its inverse, that is cosec, and tan. For them, see, tan inverse minus x or sine inverse minus x or cosec inverse minus x will give you minus the same function. That is to say, if it is cosec inverse minus x, then it will be minus cosec inverse x. If it is tan inverse minus x, it will become minus tan inverse x. And likewise for sine inverse minus x will become minus sine inverse x. And then see, for remaining three functions, the this thing, if you take the inverse of minus x, whose principal branch lies between 0 to pi, then see, it will be pi minus cos inverse x. Like cos inverse minus x is what? Pi minus cos inverse x. Sec inverse minus x is what? Sec inverse pi minus sec inverse x. And then for cot, similarly, cot inverse minus x will be pi minus cot inverse x. So we will take, that day we gave you the proof of one from each. Today we will take again one from each, so that things are refreshed in a better manner. And then see, we will be taking the more typical cases also today. So let's take. I first take here. Okay, let me take proof of this thing. So heading today is properties of inverse functions. Properties of inverse function. Inverse functions. Okay, so one each again today, just for the sake of refreshment and so that you also come in your this good mental framework to take more difficult cases. Okay, so let me prove. Okay, that day I suppose I proved sine inverse minus x is equal to minus sine inverse x. So today we will prove, first of all, tan inverse minus x is equal to nothing but minus tan inverse x. And see, the basic methodology will remain same. Only what you need to see, you need to ensure is that both x and whatever the value is there, so that is there in the principal branch. So what you will do, so this property if you have to do, so let tan inverse minus x is equal to theta. Say it is equal to theta. And then see, please do write where this minus x lies and where this theta lies. So best way would be that you just see that what is the domain of tan and theta? You know, it is from minus pi by 2 to theta, this thing tan and theta will lie here. So minus pi by 2 to this thing 0, write down like this, and then pi by 2. And how the value changes? here it is minus infinity, here it is 0, and here it is infinity. It is open interval. See, this is the domain of tangent theta, and these are the values of tangent theta in its domain, principal branch. So for tan inverse x, what the thing would be? It would be other way around. For domain will be this thing, the bottom line, and the upper line will be the values of tan inverse x function. So now obviously here, if somebody asks you where this minus x will lie, so answer would be well within its domain. So minus x, where will it lie? It will be between minus infinity and plus infinity. Okay. And what about theta? Theta will be embedded between the open interval minus pi by 2 to pi by 2. Okay. So these two things. See, this analysis, please do it and make sure that all the things they do fall well within their ambits. So tan inverse minus x is equal to theta. This implies minus x is equal to tangent theta. So what it means? Okay. So x will be equal to minus tangent theta. Okay. So this minus tangent theta, what we can write? Well, tangent we know it is minus theta. X is equal to minus theta. Okay. Let us come till this stage. Now please see, x, make sure that nowhere, see, everything is falling properly within their principal branches. If minus x is equal to this thing, then see where this x will go. You multiply with this thing. So what will happen? If you multiply with minus 1 throughout, then what will happen? This will become plus infinity. This will become greater than, this will become x minus x. So plus x, and this again this will become minus infinity. So eventually you get the same thing. This thing is nothing but same thing. Minus infinity is less than what? X is less than plus infinity. So this is what you will get it. But we don't do it, we would not be doing it, now we have understood. So here let's see, theta lies between minus pi by 2 and this pi by 2. Then obviously by the same analysis, minus theta will also be lying between minus pi by 2 and pi by 2. Easy to see. So you are well within your this thing, that because see tangent minus x, if say x is, suppose here fortunately you have the entire real line, but if had it been some restricted set, then it could well have been the possibility that if x is falling in the principal branch, then maybe that minus x might would have not fallen into the principal branch. So it is always better to look into it. Okay, so x is okay, minus theta again falling in C. So you are you can comfortably take the inverse of this thing. So what you will get, tan inverse x is equal to minus theta, and minus theta is your this thing. So it is tan inverse minus x. Theta is tan inverse minus x. Minus theta, so this thing. Okay. Then no, tan inverse minus x is theta. Okay, yes. So what you have got is tan inverse minus x minus is this thing. So multiply with minus 6. So you will get minus tan inverse x is equal to tan inverse minus x. So this or this thing you write first, this thing you write later on, you get the proof of your property. So it is easy to see, there was hardly anything difficult in it. Just to refresh you. Now see, we will take another example here in the for this thing where the principal branch is from 0 to pi. That is okay. Which what are these things? Cos, sec, and cot. So let us take sec. Let us take sec. Okay. So what it essentially means? It means that yes. Yes. So sec, this is the case where the principal branch is from 0 to pi. And I said when the principal branch is from 0 to pi, then sec inverse minus x will be what? Pi minus sec inverse x. So this is what you have to do. Sec inverse minus x is equal to pi minus sec inverse x. Okay. Let us prove this result. So as usual, let sec inverse minus x is equal to theta. And please, what is the principal branch of, first you write here the main thing. So sec theta. For sec theta you write where it lies, it from 0 to pi by 2, it is sec theta, I write it. Its principal branch. 0 to pi by 2 to pi. So basically it is 0 to pi. And how the values will change? At 0, what it is? 1. And then here pi by 2 it is infinity. And then see what it becomes. Then see it goes from minus infinity to minus 1. Yes. So this is the principal branch of sec theta. If see for sec inverse, if you want to see this branch, so it will be what? 1 to infinity union minus infinity to minus 1. In fact, minus infinity to minus 1 should have been written earlier than 1 to infinity. Then it would have made sense. But the idea is same. We can do it. So now see, minus x will lie where it is? In its principal branch. In its principal branch. So, okay, let us take two cases. See here, let us take two cases. Case 1, when minus x is the element of, say, 1 to infinity. 1 to infinity. Then if minus x, please see, minus x is the element of 1 to infinity. Then we will take, second case will be minus x is the element of minus infinity to minus 1. So when x is the element of 1 to infinity, then theta will be what? Theta will lie between 0 and pi by 2. Theta will lie between 0 to pi by 2. Okay. 0 will be included. Please mind it. 0 will be included, pi by 2 will be excluded. So here also let us be very particular about it. Minus x is the element of closed interval 1 to infinity, which is closed on the left side, open on the other side. So theta obviously will be like this thing. Two way we will look it. Okay, fine it is. So when minus x is this thing, so now, so where this x will go? X will be the element of what then? It will be 1 to infinity. So basically you write 1 is less than equal to minus x is less than infinity. Multiply with minus throughout, so what you will get? Minus 1 is greater than minus x, and it will be greater than minus infinity. So what it is giving you? It is simply giving you minus infinity is less than x is less than minus 1. So please see, if minus x is the element of 1 to infinity, then x will be the element of what? It will be the element of minus closed interval. Minus 1 to, better write, open interval minus infinity to minus 1. Okay, no issues. So what we will do here, sec inverse minus x is theta. Okay, so this thing we have written here. In fact, we would put a written that in. So I am just rubbing it. I will write this result here. Please see, same result here. X is the element of 1 to infinity, closed interval. So that thing becomes. So what we have obtained this result. That x will be the element of minus infinity to minus 1 closed interval. Here I am writing it up so that I can work out my remaining things here. Okay. Now see, sec inverse minus x is theta, so minus x obviously will be what? Sec theta. Okay. So x will be how much? It will be minus sec theta. Okay. And cos, see, sec theta. Now we can, you know, sec minus theta is what? Sec theta. So obviously we have to write it like what? Sec pi minus theta. Sec pi minus theta. And this is what now we will be looking at. Because if we will take sec inverse x, then let us see where it goes. So pi minus theta, where it goes. So let us see, if theta is here, so minus theta will be here. So see, if you multiply it throughout with minus, so what you will get? 0 is greater than minus theta is greater than pi by 2 minus side. So it means minus pi by 2 is less than minus theta is less than equal to 0. Okay, you want the value of pi minus theta, so add pi, go all the way, add pi all the way. Pi, so if you are adding pi, so what you will get? Minus pi by 2 plus pi, that will give you pi by 2 is less than pi minus theta, and then here you will be less than pi. Okay, this is the result. Now we are just pi minus theta is lying in the principal branch here between pi by 2 to pi, so we can safely take sec inverse, because x is equal to sec pi minus theta. So what does it mean? It means sec inverse x will be equal to pi minus theta. At place of theta, what we can write here? Theta value is here, sec inverse minus x, sec inverse minus x. So, and this is the result which we were looking for. This was the result which we were looking for. So, similarly, see, so all what I wish to say again is, I am summarizing it, that the for the inverse function, if you are taking the inverse of those trigonometric functions, this thing, you are taking, suppose, minus x of inverse of some trigonometric function, then if their principal branch is lying between 0 to pi, then they will be simply minus same inverse function. But if their principal branch is lying between 0 to pi, that is 3 function, then they will be pi minus and then same function. So this is property 1. We have out of 6 cases, we have already taken 4 cases. Now let's see, I will take another important property, that is the property number 2. Okay. See, property 2. What it says. Here see, what you will find, that sine inverse 1 upon x, this is equal to cosec inverse x, sine cos inverse 1 upon x, this is equal to sine sec inverse x, and then see tan inverse 1 upon x. Now please see here, all these things are, you know, well within their principal branches. In this tan inverse 1 upon x, here see, this will be equal to cot inverse x, provided x is greater than 0. X is greater than 0. And this will be equal to what? This will be equal to cot inverse x, and then pi plus, so minus pi if x is less than 0. Here see, it is different. They will remain same throughout their principal branches. But here see, because see, in tan inverse its principal branch is entirely in. So if 1 upon x, that is this thing, quantity, if it is positive, then see, it is cot inverse x, as in the other cases. But then see, here the point of question is that if tan inverse 1 upon x is where x is less than 0, then see, this will be cot inverse x minus pi. So this thing we had to verify here. Okay, so 2 cases we will be taking here. First, of course, see, we will do the simpler cases. Okay, let me take here. Okay, suppose sine inverse. Now please mind it, if sine inverse 1 upon x is cosec inverse x, then see, it means cosec inverse 1 upon x is equal to sine inverse x, and this thing you can obtain from here itself also. At place of x, what do you write? 1 upon x, so it will become sine inverse x, and this thing will become what? Cosec inverse 1 upon x. So this pairing, likewise for second cosec, same, and for tan c, it will be a bit different, because we have taken 2 cases, so that you have to be careful there. Okay. Now let me take the proof of which one? Okay. any one of them, let me take it. Okay, sine inverse 1 upon x. Okay, I will prove the property sine inverse 1 upon x is equal to cosec inverse x. This is the property. So let sine inverse 1 upon x is equal to theta. Then as usual, what you will do? 1 upon x will lie here. Mod of 1 by x should be 1 by x will be where? Between minus 1 and plus 1. And what about theta? Sorry, it is sine inverse. Okay, it's sine inverse, yes, it is okay, 1 by x, and then theta will be between minus pi by 2 to pi by 2. These are the principal branches. Because the principal branch of this thing, sine is minus, for sine what it will be the principal branch, minus pi by 2 to plus pi by 2, and this will be value of sine in its principal branches will be minus 1 to plus 1. Okay. So theta is there. Okay. So what it becomes? 1 by x is equal to how much? It's very simple, sine theta. So x, you take the reverse of this thing. 1 upon x is equal to sine, so inverting it, so x upon 1 will become what? 1 upon sine theta, that is cosec theta. Cosec theta. And for cosec theta, please see what it is the principal branch, again minus pi by 2 to plus pi by 2. So here theta is varying from minus pi by 2. So you can take cosec inverse x is equal to theta, and mind it. Now what is more important is, see, 1 upon x is lying between this thing. So and see what is the value of cosec theta? It falls always either it will be greater than 1 or it will be less than 1. The value of sin theta is always embedded between minus closed interval minus 1 and plus 1, and the value of cosec theta is away. And this will precisely happen because, see, that can also you need to make sure it develop this sort of practice. 1 upon x is this thing. So please see what it means. 1 upon x is or say 1 upon mod of x is less than equal to 1. So please see what will it mod x, because when you are dividing and the value is less than 1, so it means this value mod x will be between 0 and 1. So once you are dividing by number less than 0, so what will be the value? They will go beyond it, 1. So mod x will be greater than 1. Mod x will be greater than 1, and that is the requirement of cos, because x here, if x would have been between minus and 1, then you could have taken cosec inverse, because then the cosec inverse would have not even existed. So because the domain of cosec inverse is away from plus 1 and less than minus 1. So you are justified. So this gives you the proof here. Now let me take for this thing tan inverse. This case will be a bit different. So before I take the case of tan inverse, so to tan inverse 1 by x, please see, tan inverse 1 upon x is equal to cot inverse x. See, in your book they have given only simpler cases, and it will be equal to cot inverse x minus pi if x is less than 0. If x is less than 0. Okay. So please see how. First case, case 1. X is greater than 0. Okay. See, let tan inverse 1 by x is equal to say theta. Write down. So 1 upon x will lie where? If x is positive, so 1 by x will be positive. So positive means what? It will lie between where? 0 to tan, I will write in here, tangent theta, principal branch is from minus pi by 2 to 0 to pi by 2. And the values being acquired are minus infinity to 0 to plus infinity. So now see, These are the values. So for tan inverse theta, principal branches will be like this here. So now tan 1 by x is lying where? In the positive part, between 0 to infinity. Between 0 to infinity. So 1 upon x is where? 1 upon x is between 0 to infinity. And then theta will be where? From theta will be between where? 0 to pi by 2. Tan inverse 1 by x is theta. X is positive. So 1 by x will be between 0 to infinity, and theta will be where? It will be from 0 to pi by 2. 0 to pi by 2. Okay. 0 to pi by 2. Fine. Open interval. It should be, yes, open interval. 0 it will be 0, 0 you can include also. So here see, no, you can't include because 1 by x you are taking. So that thing you leave it now. So 0 like this. And so tan inverse, so 1 by x will be what? It will be tangent theta, no issues. So x will be what? 1 upon tangent theta. That is cot theta. That is cot theta. Now see here. Cot theta. Theta is lying where? 0 to pi by 2. Fine it is. Because this thing, principal branch of cot theta is what? 0 to pi. So this branch 0 to pi by 2 is included there in the 0 to pi. So cot and x is what? X. Now please see, if x 1 upon x is lying between 0 to infinity, then where the x will go? X will also lie between 0 to infinity. So no issues. So cot theta, safe you are. Neither x will pose a problem, it will be well within the domain, because the domain of cot theta is what? The entire real line. So cot inverse x will be equal to theta, and theta is what? Tan inverse 1 upon x. So you prove the first result. Now second result will be where you had to make certain changes. Let me see how. Now see, case 2, when x is less than 0. Okay, then tan inverse 1 upon x. Okay, when x is less than 0, so where they will lie? 1 upon x will lie wherein? Okay, I will grab it later. Let us do it completely again. Tan inverse 1 upon x is theta. X is less than 0 means negative. So tan inverse. Now see, negative means what? It is between minus infinity to 0. Okay, so 1 upon x will be between minus infinity to 0. And then see, it will be, theta will be from here to here, from minus infinity pi by 2 to 0. Very simple. Okay. Now see. So this implies what? This implies that 1 by x is equal to tangent theta. And x will be what then? Cot of theta. Cot of theta. Now please see. Cot theta, if you take the cot inverse here, so theta, cot inverse x will be theta. So cot inverse, here theta is minus pi by 2 to 0. Whereas the principal branch of cot is what? 0 to pi. So this will not be there. Please see. Here you cannot take the inverse. For simple, cot inverse x is, if it is theta, then theta is lying between minus pi by 2 0. Whereas the principal branch of cot theta is what? Of cot inverse is what? It is 0 to pi. 0 to pi. So this minus pi by 2 0, you are getting away from jumping your principal branch of cot theta, cot inverse theta, because cot inverse x will be, you will be writing theta. So you will be jumping it. So please see what you can do. And theta here also need to be changed, because cot theta, theta is not in its principal branch. Theta is between minus pi by 2 0. For cot theta, see, the principal branch is 0 to pi. So you have to make sure that this theta comes within 0 to pi. And for that, what you can do? For what? Let us see what we can do here. Yes. So what we will do is, we will write it as x is equal to cot theta. Okay, so we will write here let us write pi by 2 minus theta. So cot will be cot of pi minus theta. Let us see where it goes. Or it will be minus cot this thing. Cot theta we can write like this thing, minus cot pi minus theta. Because cot pi minus theta will be what? It will be minus cot theta, and this minus will, with this minus will become plus. So what we will be writing like this. Okay, are we justified in writing this like this? That we need to make sure. Okay, so minus x you will be writing tan inverse 1 upon x. 1 upon x is tangent theta, so x you are writing cot theta. 1 upon, okay, cot theta. Cot theta, it will be pi by 2 or pi only. Okay, pi cot pi minus theta. Pi minus theta will go where? Let us see. Okay, let us see. Minus theta will go where? Multiply this thing by minus, so it will become plus pi by 2 and greater than minus theta greater than 0. Okay, and then see you add this is minus theta pi by 2 minus theta, this is pi by 2. Okay, fine. So better what we can do is it is x 1 upon x tangent theta, x is equal to cot theta. X will be cot theta. Cot theta we can write like this. Okay, cot inverse x is equal to theta. So minus theta, where is it? Cot pi minus theta. Okay, if I add pi here, then things will be wrong. Just let me check it. Minus pi by 2 to 0. What? 1 upon x is tangent theta. Tan inverse, you say tan inverse 1 upon an x is less than 0. X is less than 0, so minus pi by 2 to 0. Minus pi by 2 to 0 theta. So theta will lie where? Minus theta will lie here. So minus theta will x is less than 0. Okay, minus theta is this thing. So what it means? It means that 0 is less than minus theta is less than pi by 2. Okay, so if you add here pi by 2, if we add here, so I think we will get to the point or not. Okay, pi by 2. No, something gone wrong here. Let me just check it. 0 minus pi by 2 is theta. 1 by x, 1 by x, where it is? You have it on this. All is 2. Okay. Okay, let us do one thing then. We want cot theta. We will not put here. If I put pi plus theta, see, cot pi plus theta is what? It will be in this quadrant, third quadrant, or if you take, yes, it will be positive. So I can write x is equal to cot pi plus theta. Now it's okay. Now pi plus theta, let me check it where it lies. Yes. Now it's okay. Please see. My theta lies between minus pi by 2 to 0. Fine. So 0 minus theta, this pi plus theta. So add pi all the way. What you do? Add pi all the way. So what you will get? Minus pi by 2 plus pi is less than theta plus pi is less than 0 plus pi. Fine. So theta plus pi, what you are finding? It is lying between what? Minus pi by 2 plus pi is what? Pi by 2, and this is what? Pi. Well within, yes. Now it's okay. Now it's okay. So x is equal to cot pi plus theta. Cot pi plus theta. Pi plus theta is lying between pi by 2 to pi, and that's why the principal branch of cot is what? 0 to pi. Please see. Now it's okay. Please see here theta was between minus pi by 2 to 0, which was not lying in the principal branch of cot theta. So you had to do some homework. So what we need to do is, in this cot theta, we would be writing cot pi plus theta. Cot pi plus theta is again cot theta only. And then we have to show that pi plus theta actually falls within the principal branch of cot theta. Principal branch of cot theta is what? 0 to pi. So that is what we have shown. Pi plus theta is lying between pi by 2 to pi. So we are safe now. So what, see, once again see. 1 upon x, we have already seen, minus infinity to infinity. So x will lie where? It will again lie between minus infinity to plus infinity. Plus infinity. See, no issues. And here see, and this thing, this domain of cot, this range of cot is what? Minus infinity to infinity. So here you are justified. Now you are justified. Please see, this is important point. X, 1 upon x tangent theta, x is equal to cot theta. I can't write. I have to change my cot theta because theta is lying minus pi by 2 to 0, which is not in the principal branch of cot theta. Principal branch of cot theta is what? 0 to pi. 0 to pi. So we had to change this thing in order, because see, if we will take cot inverse x, then this thing should fall within the principal branch of cot theta. And now once it has fallen, then of course you are justified. Now you can write cot inverse x is equal to pi plus theta. And then pi plus theta, theta is what? Theta is your tan inverse 1 by x. Tan inverse 1 by x. And so your property is proved. This is cot inverse x. And if you bring this by this side, you get this result. Tan inverse 1 upon x is equal to cot inverse x minus pi. Minus pi. When x is less than 0. So see, this property is not given in your book. So please understand it. And this sort of analysis we would be doing almost in all the good questions. Now let us take the third property. This is property 2. Only here it will make a difference. For rest of the things, whether it is sec inverse 1 by x, sec inverse 1 by x, it will be again see what? It will be cosec inverse sec cos inverse x, sin inverse 1 by x, cosec inverse x, cosec inverse 1 by x, sin inverse x. Only the difference you will encounter over here. So this is important property. Now the third property. Now the third property we will take, and that says that yes, sin inverse 1 by x, sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. And likewise the third property says that sec inverse x plus cosec inverse x is equal to pi by 2. So now here see, they are not their inverses. They are not their inverses. So third property, write down sin inverse x plus cos inverse x. This is your property third. It is pi by 2. Likewise, tan inverse x plus cot inverse x is equal to pi by 2, and then sec inverse x plus cosec inverse x is equal to pi by 2. We will take here two properties. First we will take this one and then we will take this one, so that you are comfortable with the working of these properties. So let me take first sin inverse x plus cos inverse x. Let us write down. So let sin inverse x is equal to theta. Let sin inverse x is equal to theta. So please see, we will be first writing here. What is x here? X will lie between minus 1 and plus 1. What about theta? Theta would be going from minus pi by 2 to plus pi by 2. And principal branch we are writing here. And you know these things, that the principal branch of sine inverse x is minus pi by 2 to plus pi by 2, and so on and so forth. Now sine inverse x is equal to theta, so what it will be? X is equal to sine theta. Find it is. Now, what we can do here? Cos inverse x we want now. Please see, x is line between this thing. So can we find this thing? X can we write like this, cos pi by 2 minus theta. We can safe write it. But then we have to make sure that this pi by 2 minus theta, it should fall within the principal branch of cos theta. One thing. Because we have to do it like this thing. Then only we can write cos inverse x is equal to pi by 2 minus theta. X is okay. X is minus 1 to plus 1. Both for sine and cos, their domains are respectively what? Minus 1. Close interval minus 1 to plus 1. So x is okay. We have to simply see that pi by 2 minus theta, whether it is falling within the principal branch of cos or not. So that analysis we have to take from now. So theta lies between minus pi by 2. So minus theta will lie here. Again see, it is simple. Please remember, if a number is lying between minus a to a, suppose some number x is lying between minus a to plus a. So what will happen? Either it will lie here or on this side. If it is lying here, so its minus will be this side at the same distance. If it is this side, then it will go on the other side. So eventually it doesn't make sense. You can write minus theta will also lie between this thing. Or if you want to be ensuring your result through rigorousness, then what you can do? Multiply with minus pi and then change the inequalities and all that. Hold on. Yes. Just a minute. Is it okay? Clear? So this is how. Now pi by 2 minus theta. I will write here now. Pi by 2 minus theta, I will show it here to you. Minus theta is lying between where? So you have already checked it is lying between minus pi by 2 to plus pi by 2. You want pi by 2 minus theta. So what you will do? You will add pi by 2 throughout. So adding pi by 2 throughout means what? Minus 2 plus pi by 2 inequality minus theta plus pi by 2. And this thing is what? Pi by 2 plus pi by 2. So what you get is that this pi by 2 minus theta, it is lying between what? 0 this side and this side is pi. This side is pi. So you are safe. Here pi by 2 minus theta is well within 0 to pi. So what you can write? Cos inverse x is equal to pi by 2 minus theta, or this thing you can bring this side. So cos inverse x plus theta is equal to pi by 2, and in place of theta what you can write? Sine inverse x. Cos inverse x plus sine inverse x is equal to pi by 2. So this is how you can get the result. This is how you will get the result. Let us take this third property of sec inverse x plus cosec inverse x is equal to pi by 2, because again see there you have to make sure that these principal branches are maintained throughout. Principal branches are maintained throughout. So now we can prove sec inverse x plus cosec inverse x is equal to pi by 2. Okay. Please see where x will lie. For both sec and cosec x, what the thing should be? That mod x should be greater than equal to 1, because for both of them. So here see x will lie where between it will be greater than 1, that is 1 to infinity, or minus infinity to minus 1 in that union. So both cases. Now then branches are different. Sec inverse x, yes. Please see, I will be writing here. You will be you should be careful enough here to understand that. See, I will write here. I will write the principal branch of sec theta and that of cosec theta. From there you can find it out. Sec theta 0 to pi. So it is 0 to pi by 2 to pi. And then what the thing is that this pi by 2 will be excluded. So this is how you write like this also, that sec is 0, sec 1 cos 0, it is closed, then pi by 2 open union pi by 2 to pi, and this is closed. Is it coming in your screen, that corner? No. Okay, I will write here. Please see sec theta. See, it is what? From sec theta, yes, its principal branch is 0 to pi. So how you are going to write? 0 to pi by 2. Pi by 2 is excluded. Union pi by 2 to 0 to pi. Okay. Closed. This is coming in your screen. It's okay? It is coming. So now, and what are the values? It is 1 to and pi by 2 infinity. So close interval open, and union pi by 2, it is minus infinity, and cos pi to minus 1. Okay. So this is how sec theta works here. So sec inverse x, its principal branch will be this thing. For cosec theta, I am again writing cosec theta, it is from minus pi by 2 to plus pi by 2. So it is cosec minus pi by 2 to 0. 0 will be excluded. Union 0 to pi by 2. Right, it is included. What are the values? Sine, it is minus 1 to minus infinity, and here it will be from infinity to 1. This is how the things move on. For giving the proof, we see x here, both of them are same. Minus 1 to infinity here, and this thing same. About this thing, so how you do the proof. So first see, first let us assume that x is positive. X is positive means what? X is lying between where to where? Between plus 1 and infinity. Plus 1 and, this is our case 1. X lying between 1 and infinity. Okay. So let sec inverse x is equal to theta. So where this theta will lie? Provided x is positive. X is positive. So very simple. Sec inverse x is positive, so it will lie between 0 to pi by 2. So theta will lie where? This is 0 to pi by 2. 0 to pi by 2. See, this included and this excluded. Very good. Now, sec inverse x is equal to theta. Find it is. So now please see. So what we can write? X is equal to sec of theta. Good. Fair. No issues. Because we can safely write it. Now sec theta. Now at place of sec, what we want? We want cosec. So this thing is what? Cosec pi by 2 minus theta. You are in the first quadrant. In first quadrant, all of them are positive. But then see, and this is x is equal to. Now see, we have to check it where pi by 2 minus theta, whether it is in the principal branch of cosec theta when x is positive. Only this thing we need to ensure. Now cosec theta, when it is positive, it should lie between 0 to pi by 2. So this only aspect we have to see, that pi by 2 minus theta, will it lie between this thing 0 to pi by 2 or not? If it is lying, then fine enough. So as usual, minus theta inequalities will change. So 0 multiplied with this thing minus theta is greater than minus pi by 2. Okay, add pi by 2 because you want pi by 2 minus theta. So pi by 2, or see, first you rewrite this thing. You can write it as minus pi by 2 is less than minus theta, and then this is less than 0. Add pi by 2 now. So adding pi by 2, what you will get? Minus pi by 2 plus pi by 2 is less than pi by 2 plus minus theta, and then this is pi by 2. So this is 0 is less than pi by 2 minus theta. This is what you actually want, and this is less than pi by 2. And this is now you are seeing, because 0 to pi by 2. You are lying between 0 to pi by 2. So you are comfortable. See, this is actually what you wanted to prove. Because cosec, when you are writing here this thing, so cosec pi by 2 minus theta, if you are writing, then you need to make sure that this pi by 2 minus theta should fall within the principal branch of cosec theta. Else you will encounter problem. See, x is okay. X is always x is positive. It will lie between 1 to infinity. So no issues. And from here you can see that when in cosec inverse x, when x is this thing, lying a positive number, that is lying between 1 to infinity, then the its range should lie between 0 and pi by 2, and this is lying between 0 and pi by 2. So we can now take cosec inverse x is equal to pi by 2 minus theta. Theta is what? Your sec inverse x. Sec inverse x. So sec inverse x, you can bring it here and do sec inverse x plus cosec inverse x is equal to pi by 2. The result is proved. For the case 1, when x is greater than 0. Let us see for the second case, because we have to take both the cases. So second case we will take exactly on the same lines. Only what, see, you need to practice here that they are falling within their principal branches. So let case 2, when x is less than 0, then we will prove sec inverse x plus cosec inverse x is equal to pi by 2. So again do the same thing. Let sec inverse x is equal to theta. Do write there all these things. And x is negative. X is negative, please see, sec inverse. X is negative means it will lie here. And then theta will lie where? Between pi by 2 and pi. See, this is very important. And as such, see, these principal branches you should write. This is the principal branch of sec, and this will be the principal branch of sec inverse, because whatever the range of sec is in the principal branch, that becomes the domain of inverse function. Likewise for cosec theta. So first you write them, and then you analyze it. Then see, you will reach the depth. So now please see, let sec inverse x is theta. So where will be x? X is less than 0. X is less than 0. It means x will be from where to where? From minus infinity to minus 1. Okay. And theta is particularly important. Minus infinity to minus 1. Okay. So it will be between, theta will be your from pi by 2 to pi. It is closed. It is less than equal to. It is less than equal to. Closed interval is like this. Okay. So what it means? X is equal to sec theta. Okay, no issues. Now you want to convert it into cosec theta, because you want the result cosec inverse x. Yeah. So what you can do? Now cosec, if you want to write it into cosec theta, then of course see cosec pi by 2 minus theta is sec theta, no doubt about it. So let us see if whether when this x is negative, when x is negative, then again pi by 2 minus theta, will it lie in the principal branch of cosec theta or not? That is the main issue. That is the main issue, and that we will find. So pi by 2 like here. So minus multiply with minus. So what you will get? Minus pi by 2 is less than is greater than. When you are multiplying with this minus negative sign, then the sign of inequality reverses, and this will be greater than minus pi. So what it is? Minus pi is less than minus theta is less than, you get write as like this. And then, so minus theta, add pi by 2. So minus pi plus pi by 2, adding. Inequality, if you are adding something, it hardly changes the inequality. Minus pi by 2 plus pi by 2. So what it becomes? Here, minus pi by plus pi by 2 is minus pi by 2 is less than pi by 2 minus theta. Whether you write minus theta plus pi by 2 or you write pi by 2 this thing, and this thing goes to 0. Now see, pi by 2 minus theta lies between minus pi by 2 and 0. And this is precisely the principal branch of cosec. When see, cosec principal branch is what? Minus pi by 2 is 0 pi to pi by 2. And the minus pi by 2 to 0, see, this thing, pi by 2 minus theta is lying where? Between minus pi by 2 and 0, when x is negative. And see, here all the value of cosec theta are negative. So now you are comfortable. X is negative between minus infinity and minus 1. Okay, cosec pi by 2 minus theta lies between the principal branch of cosec theta. So cosec inverse, now you are justified in taking pi by 2 minus theta. And then put the value of theta. So what you will get? Cosec inverse x. Theta is your sec inverse x. So plus sec inverse x is equal to pi by 2. Property is proved for both the cases when x is less than 0 also, and earlier you proved it for x greater than 0. So these three important properties of your book we have taken. Now with these, so basically see, now we will be doing few more things of your book, few properties only. Today we will take all the properties, and we will see that there is no problem at all here. And then we will give you some more results of. So first we will remain confined to the book, then we will go beyond that also. So in your book, see, the first property which they have taken is, now tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. When this result is when xy is less than 1. Xy is less than 1. Okay? Too good? Now please see, I am writing the domains here for your convenience so that you don't tan inverse x. What is its domain? Tan inverse x entirely. Because for tangent theta, its domain is from minus pi by 2 to plus pi by 2. And so I am writing here tangent theta. It's minus pi by 2 to 0 and to pi by 2. Open interval, we see, and the values which it requires is what? Minus infinity to 0 to plus infinity. And remember that open interval. And then see, so here I tan inverse theta I am writing here. So this is your most important thing, just to check that what are the values, are fitting in your principal branches or not. So that aspect we have to see, and then we can do it. So what is the condition here? Xy is less than 1. Let us see. So what we will do, please see, tan inverse x is equal to theta 1 and tan inverse y is equal to theta 2. We will write where are our theta 1 plus theta 2. Okay. So theta 1 will be from where to where? Yes. We see theta 1 will be from where to where? Between minus pi by 2 to plus pi by 2. Sorry, it is open interval. So minus pi by 2 to plus pi by 2. And likewise your theta 2 will be from minus pi by 2 to plus pi by 2. Okay. Now I will give you an interesting result. Xy is less than 1. Okay, no issues. Firstly, I will show that this result holds when xy is less than 0. When xy is less than 0. Case 1 I am doing it. Case 1. Because see, what you want to show that this is 0 and this is 1. If xy is less than 1, the product of this thing is on the left side of this thing of 1. Then see your result is like this. Okay. Now see cos. Please see. If case 1, when xy is less than 0, what does it mean? This simply means one of them is positive, other of them is negative. Please see, either x will be positive and y will be negative, or if x is negative, then y has to be positive. So one positive, one negative. So please see, if suppose x is positive, so theta 1 will lie where? Theta 1, if it is positive, please see. So it will lie between what? 0 to pi by 2. And theta 2 will lie where? On the other side. Because if y is negative, then it will lie here and the value will be between minus pi by 2, 0. And now see, it is simple to see that both, if see theta 1, please see here, I am writing here minus pi by 2, please understand this thing. This is of crucial importance. If see theta 1 lies in this plus half and theta 2 lies here, then their sum, theta 1 plus theta 2, will remain confined between minus pi by 2 and plus pi by 2. Please see, if one of them is lying in this half, other one is lying in this half, then what is the thing? From here, see, suppose, and what will be the plus? Do depending upon this distance is greater or this distance is greater. If this distance is greater, then what you will do? This much and add you this much. So from here you will be going, say, this much on the left side. So resultant will be this much of thing. But anyway, whatever their values, theta 1, theta 2, if they are lying on the right side and left side of 0, then their sum will always be between minus pi by 2 and plus pi by 2. Do depending upon which one is located farther. So that will be confined between minus pi by 2 and plus pi by 2. So what does it mean? Theta 1 plus theta 2, if they are lying, so what essentially we are proving is that, you see, if this is the case, that is x is greater than 0, y is greater than 0, it means theta 1 is lying between 0 to pi by 2, and here y is less than 0, y is less than 0, means that it is lying between, theta 2 is lying between minus pi by 2 to 0. So that is to say, one is lying on the left side of the 0 and minus pi by 2, other is lying in the same. So theta 1 plus theta 2 will definitely lie between minus pi by 2 to plus pi by 2. See this aspect, please see and understand it also. So this is a good thing, result. I have shown you geometrically also. See, what do you do? Suppose this thing is greater. So first you add one thing, suppose this is theta 2, this one theta 2. Then theta 2 you want to add it. So in number line what do? You will go, theta 2 is negative. So from here you will be going to this thing. And see, since the absolute value of theta 2 is greater, so you will be on the, so it will be negative value, so it will be this way. Otherwise if theta 1 is somewhere here, theta 2 is here, then theta 1 plus theta 2 will be on the right side, positive value. So this is interesting result. Why see we are so particular? Because see, we can see what it is. It is nothing that tan A plus B is what? Tan A plus tan B. X is what? Tangent theta 1, tangent theta 2, tangent 1 minus tangent theta 1, tangent theta 2. So we need to show that theta 1 plus theta 2 is embedded within the principal branch. Within the principal branch. Okay. So now this is what we. So one result safely which we can deduce is that xy is less than 0. So what we have shown that theta 1 plus theta 2 will be between minus pi by 2 and plus pi by 2. And the same result we will show here. If xy is less than 1, then again we will show that theta 1 plus theta 2 is less than, is lying between minus pi by 2 and plus pi by 2. You may wonder right now that why I am insisting that theta 1 plus theta 2 should lie between this thing. I will show it to you. Suppose you take xy is less than 0. Then this result will hold good. Why? For simple reason. Then see, rest of the things are too simple. Because if tan inverse x is theta 1, tan inverse, so what you will write? X is equal to tangent theta 1. And here what you will write? Y is equal to tangent theta 2. And then see what you will do. Then write tangent theta 1 plus theta 2. Please see, theta 1 plus theta 2, it is important because it should fall within the principal value branch of the tangent theta. Tangent theta principal branch is what? Minus pi by 2 to plus pi by 2. So that is why we are proving for all the cases. Just now I have proved it that when xy is less than 0, then of course theta 1 plus theta 2 is lying between minus pi by 2 to plus pi by 2. Because see, once we establish this result, then giving the proof is too simple a thing. How? Because tan A plus B, you know it is what? Tangent theta 1 plus tangent theta 2 upon 1 minus tangent theta 1 tangent theta 2. Result is no important. Tangent theta 1 you have assumed what? X and this y. So this is x plus y upon 1 minus xy. This whole thing is tangent theta 1 plus theta 2. Okay. It can be any real number only. So you are justified in taking the inverse. So theta 1 plus theta 2 is what? Tan inverse this thing, and the result is proved. X plus y upon 1 minus xy. And theta 1 theta 2 is what? They are nothing but tan inverse x and plus tan inverse y. So result is proved is equal to tan inverse this x plus y upon 1 minus xy. Result will not take much time. See, so result you have shown xy is less than 0. So as soon as you show that you are well within the principal branch, then see there is hardly anything to be shown, because you will just apply the formula tan A plus B, you will get this much of thing, tangent theta this thing, you will put the values, and then see you will take the inverse, and theta at place of theta 1, theta 2, what you will get? Tan inverse x and tan inverse y, you will immediately get the result. Now see, I will take the case, so for this case you have already shown. The case next is too good for you to understand it. Now see, for when xy is less than 0 we have shown. So what the thing is, here it is 0 mark, this is plus 1 mark, so you are on the left side of plus 1 mark. You have already proved the result when you are on the left of 0. So now the only thing is that you are between 0 and 1, that you have to show that this result holds good. You are between 0 and 1. So that case we will now take it up. Okay. Yes. So now, so xy, where it is lying? Xy is lying between 0 and 1. Open interval is fine. That is to say it is positive. Product of x and y is positive. Product of x and y is positive. Mind it, what is x? X is tangent theta here, and y is what? Tangent theta 2. This much of thing you have already seen. Now I will write here because xy 0 is less than xy is less than 1. Now if I can show it for this thing again that this result holds good, then my first this xy less than 1 will be proved. Now xy, okay, let us see. So what it essentially it means, xy is positive, one thing. Positive means what? Both x and y will be either positive or both of them will be negative. So first case let us take. Case 1 let us take x is greater than 0, y is greater than 0, and then xy is lying between this much of thing. This much of thing. Now what it implies? This implies 0 is less than tangent, x is what? Tangent theta 1 into tangent theta 2 is less than 1. Please see. Both x is greater than 0, y is greater than 0, and this thing is 1. This is the first case. Second case will be similarly. Both of them are negative, because then still xy will be positive and lying between 0 and 1. Three things are there. So first we are taking the first case when both x and y are positive, and then see, and the product is lying between 0 and 1. Then let us see that this formula still holds good. So what this thing implies is, okay. And remember that x tangent theta is what? X positive, tangent theta positive. So now see what this thing gives you is tangent theta 1 is less than 1 upon tangent theta 2. This is left right inequality will imply this thing. So this is what? Tangent theta 1 is less than 1 upon tangent theta is what? Cot theta 2. Okay. Fine it is. Now, how it proves? that theta, now see cot theta 2, and cot theta 2 we can well write to be what? Tangent pi by 2 minus theta 2. So you got a very important result, tangent theta 1 is less than tangent pi by 2 minus theta 2. Now I will tell you. Now see, you will be making use of the very important property here. You know tangent function is what? Increasing function. As you go from minus pi by 2 to plus pi by 2, then see what is the graph here? It comes like this. Please see. It is minus pi by 2, it is plus pi by 2. So tangent theta is always an increasing function. Here it is negative, negative 0, then plus 1, plus 2, plus 2, and ultimately at pi by 2 it is getting towards infinity. At minus pi by 2 it is getting towards infinity, and throughout as you go from minus pi by 2 to plus pi by 2, the values are increasing. So increasingness here will imply what? Now see, theta 1 will be less than pi by 2 minus theta 2, because the tangent theta 1 and tangent this thing are within that this thing. But we see one more important result which we have forgotten right now is that we have to show that pi by 2 minus theta 2 should also lie between the branch, and it is easy to show because tangent theta 2 is positive. Please see y is tangent y is equal to tangent please see where it is. Theta 2 is tangent y, tan inverse y is positive, y is you have taken x positive, y positive, so tangent theta 2 is y, so theta 2 will lie where? Theta 2 will obviously lie between 0 to pi by 2, 0 to pi by 2, tangent 0 to pi by 2, okay. So theta 2 is lying between 0 to pi by 2, okay. Pi by 2 minus theta 2 will lie where? Again see, this inequality will fetch you what? Minus theta 2 will be less than 0. So adding pi by 2, what you will get? 0 is less than pi by 2 minus theta 2 is less than pi by 2. So please see, pi by you are well within the principal branch, and therefore tangent, because if you are away from the principal branch, then of course you can't say that it is increasing. And you both theta 1 and this pi by 2 minus theta 2 has to be within their principal branch, that is minus pi by 2 to plus pi by 2, and then you can say that tangent theta 1 is increasing function, therefore you are concluding theta 1 will be less than pi by 2 minus theta 2, because as you are going from left to right, please see the graph, as you are going from left to right, then the values are increasing. So this is the higher value, so pi by 2 minus theta will take higher value in comparison to theta 1, so theta 1 will be less than pi by 2 minus theta 2. This is to say that theta 1 plus theta 2 is less than pi by 2. Please see, you have come to your result. This is the result which we were looking for. Because once we can obtain this result, theta 1 plus theta 2 is less than pi by 2, then see, there is hardly anything in the proof. Proof will come immediately with a comfortable ease, because what you are doing, x is tangent theta, y tangent theta 2, and you will simply calculate what? Tangent theta 1 plus theta 2, and this is what? Tangent theta 1 plus tangent theta 2 upon 1 minus tangent theta 1 tangent theta 2. So this is what? X plus y upon 1 minus xy. Tangent theta 1 plus theta 2. Now theta 1 plus theta 2. See, since you are within the principal branch of tangent, theta 1 plus theta 2, therefore, next step will be what? You can immediately take the inverse, and you will get theta 1 plus theta 2 is equal to tan inverse x plus y upon 1 minus xy. And at case of theta 1 plus theta 2, you put their respective values, tan inverse x and tan inverse x and tan inverse y, and you get the result. So there is hardly anything difficult in it. Only what you need to show is that under these conditions, you can come to your principal branch. And that is why, see, xy is less than 1. Now all the cases covered. No, that negative one remains. X is less than 0, y is less than 0. Then see, this result is true. I will show you that this third result is not a new result, because once you have proved this result for x greater than 0, y greater than 0, then immediately you can get it for the other result also. How? Let tan inverse theta 1, tan inverse y is equal to theta 1, and x is less than 0, y is less than 0. So So x is less than 0, y is less than 0 means what? Minus x is greater than 0. This implies what? Minus y is greater than 0. Okay, so what do you do here? Everywhere you change this thing, this result. Because this is not going to change. X, y is less than 1. You can then write to be what? Minus x minus 1 is less than 1. So if now if you result this thing, x, y is less than 1, then minus x will be what? Positive. If x is negative, y is negative, then minus x minus y will be positive. So what you do here, you replace the value here with minus x minus y everywhere. So what you will get? Tan inverse, please see, minus x plus tan inverse. See, if your x is less than 0, y is less than 0, then minus x will be positive, minus y will be greater than 0. Therefore, see, by virtue of this second result, in this formula, what you will write? Tan inverse x, tan inverse y is equal to tan inverse x. Wheresoever x and y are coming, you simply replace it with x and y. 1 minus x minus y. This thing. And here, x, y is less than 1. So, let it be, whether you write x, y less than 1 and minus x minus y is less than 1. So, what it is? You know the property. Because tan inverse minus x is what? Minus tan inverse x. So, this is minus tan inverse x plus minus tan inverse y is equal to. Here also you take minus sign common and bring it here. So, what you will get? Tan inverse x plus y upon what this thing? It is minus x minus y. It is 1 minus xy. And this minus goes all the way. So, you get the same result. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So, not a new result. See, this result will apply. This is, we are not derived it independently. You could have well derived it independently the way we have derived the second result for x greater than 0, y greater than 0. But here, see, I am purposely not deriving it that way. I am taking it by indirect method. But if you wish, you can derive it independently. That is, you put here theta 1 is lying between minus pi by 2 and 0. Because x is negative, and likewise this thing, and then do the same analysis, you will get the same result. So this is all about this thing. We will later on also prove that if xy is greater than 1, then how? What will be the changes? Then it will be plus pi something. And so I stop it here. I will take one more session on the property because this thing, and with the hope that you will this thing. I will take. Okay. One more problem. I wish to take 2 more properties here. Okay, quickly I will go through them so that at least you can try the questions of your book, if nothing beyond that. Okay, those 2 properties, let me take it. They are good. See what it is. You have to do 2 tan inverse x is equal to this thing, sine inverse 2x. This is sine inverse 2x upon 1 plus x square, and other property is 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. Here the condition is x is greater than 0, and here the condition is that mod x is less than 1. Mod x is less than 1. Let me check it. Yes, it is given in your book. So mod x is less than 1. Okay, and that is x is greater than equal. It is equal to 0 also. So first here, see these 2 properties also, because as far as solving of the questions of your books are concerned, these 2-3 properties will suffice the purpose. Okay. Let's see. For this first property, okay, 2 tan inverse x. So here for proving first property, what you assume that tan inverse x is equal to theta. So what it means? It means x is equal to tangent theta. So where this theta will lie, yes, because you know this theta will lie between minus pi by 2 and plus pi by 2. Okay, because tan inverse x is this thing, and x will lie here. It can be any real number with minus infinity to plus infinity. So x is equal to tangent theta. Okay. Now please see sine inverse this thing. Now see what is this 2x upon 1 plus x square? Let us simplify it. First of all, 2x is what? X is tangent theta. So 2x will be 2 tan theta upon 1 plus tan square theta. This is nothing but 2 tangent theta upon 1 plus tan square theta is sec square theta, and this will eventually give you sine 2 theta. So here see, so with this 2x becomes equal to sine 2 theta. How? 2, it is sine theta upon cos theta, one cos will go and then one cos will come up. You simplify it, very easy, it will come sine 2 theta. And therefore see this thing, now right hand side let us take. Right hand side is what? Sine inverse 2x upon 1 plus x square. So what it is? Sine inverse sine 2 theta. Sine inverse sine 2 theta. So sine inverse sine 2 theta is what? 2 theta. Because you have already seen that if a function is invertible, then f o f inverse is equal to iy, provided f is from x to y. And f inverse o f is what? ix. ix, f is from x to y. So here it will be sine inverse sine 2 theta. So it is will be 2 theta only, and right side is what? 2 tan inverse x, and tan inverse x is what? 2 theta. So both left side right side equal. So you get the this thing, equivalence of this thing. So first property is true. Now why you have written this is mod x is less than 1? You have nowhere used it. Yes. Because for the simple reason that see here 2x upon 1 plus x square has its value need to be between minus 1 and plus 1. Because that's why if mod x is greater than 1, then see it could be problematic also at times. Because yes, whether it will be problematic or not, that we have to look into. Mod x is greater than 1. If it is greater than 1, then will it be problem? I don't think mod x is less than it is. Yes, see, because you want to be. Yes, please see. This value has to be between in the minus 1 and plus 1, and this will be because 1 plus x square is always greater than 2x. 1 plus x square is always greater than 2x. Yes, so this has to be between minus 1 and plus 1. This has to be between minus 1 and plus 1. That's the reason that this is mod x is less than 1. Similarly, this second property, 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square can be easily proved. Let us see. Second property. Only you need to see that you are well within your here x is greater than 0. The cases like mod x, if it is greater than then what will happen? So that also we will deal later on. Here, of course, see this thing is okay. 2 tan inverse is equal to this thing. So left hand side, same thing. Tan inverse x, you put theta. So x will be what? Tangent theta. X is tangent theta. Now calculate right hand side. So left hand side is what here? Left hand side is what? 2 theta. 2 theta. Left hand side value is this. Right hand side value what it is? Please see. 1 minus x square upon 1 plus x square what it is? It is nothing but 1 minus tan square theta upon 1 plus tan square theta. Which on simplification will give you what? Sin cos square theta minus sin square theta upon cos square theta plus sin square theta, and that is nothing but cos of 2 theta. Cos of 2 theta. And the right hand side, first you calculate this thing. So right hand side is what? Cos inverse this thing. So right hand side now will be cos inverse cos 2 theta, that is 2 theta. Both left side, right side is 2 theta is fine. Now again the question will come, why you have not taken x greater than, why you have taken x greater than 0. Okay, I leave it this as a homework for you people to ponder it over. because we have shut our this prescribed limit, है ना? And many of you would have exhausted your data also. So I will be sending the video, no issues, by late night. So thank you. Again, see one thing more. I will be taking your classes alternate day, 12 o'clock on the same Jitsi app with the same room number. Thank you.